Welcome. My name is Bob Tickleman. I'm a Microsoft technical trainer, and I'm excited to be your guide to this delivery of what you want to know when you want to know it. Welcome to the Develop with DevOps module. This module is designed to provide you with an understanding of how to streamline your software development projects by applying DevOps principles and practices. Whether you're new to DevOps or looking to enhance your development skills, this module will guide you through the essential concepts and tools that drive successful DevOps implementations. The key topics covered are source control and version control, where you will learn the importance of managing changes and source control files and other types of files. You will see how version control systems like Git and GitHub help track changes, facilitate collaboration, and support parallel development. In managing source control with GitHub, you discover how to use Git to manage your source control effectively. This includes creating repositories, committing changes, branching, merging, and collaborating with team members. In managing source control with GitHub Flow, you explore the GitHub Flow workflow, which provides a simple and effective way to manage your development process. You will be introduced to the branches, opening pull requests, and merge changes into the main code base. You will also see the concept of continuous integration, or CI. You'll see how it helps automate the process of integrating code changes into a shared repository. You'll see how CI tools can automatically build and test your code, ensuring that it is always in a deployable state. You'll see how the impact of shift-left testing, which involves testing early and often in the development process, as well as you'll see how to integrate testing into your CI pipeline to catch issues early and improve software quality. You'll see a similar process for shift-left security, which involves incorporating security practices early in the development process. You'll see how to integrate security testing into your CI pipeline to identify and address vulnerabilities before they reach production. By the end of this module, you'll have a solid foundation in DevOps development principles and practices, enabling you to drive continuous improvement and deliver high-quality software more effectively. Now let's get into this. Source control and version control are essential practices for any DevOps team. They help manage changes to your code, facilitate collaboration, and ensure the reliability and stability of your software. By implementing these practices, you can streamline your development process and deliver high-quality software more effectively. Let's start with source control. Source control, also known as source code management, is a system that manages changes to source code files. It tracks modifications made to the code, allowing developers to collaborate on projects without overwriting each other's work. Source control systems keep a detailed history of changes, making it easy to review and revert to previous versions if needed. Popular source control systems include Git, Subversion, Microsoft Team Foundation Server, and Azure DevOps. Now let's talk about version control. Version control is a broader concept that includes source control, but extends beyond it. Version control systems manage changes to any type of file, not just source code. This can include documentation, configuration files, and other project-related assets. Version control systems provide features such as history and version tracking, rollback and recovery, branching and merging, and support for automation, collaboration, and parallel development. Examples of version control systems include Git, SVN, and Azure DevOps. Both practices share common goals of tracking changes, facilitate collaboration, and maintain the integrity of the project. By using version control systems, teams can work on different parts of a project simultaneously, automate various aspects of the development process, and ensure that all changes are properly documented and reversible. There are a lot of terms that get tossed around in DevOps that sound the same but may be different. That can be confusing, such as deliver and deploy. They sound the same but mean something different. More on this later. Git and GitHub are another example that I want to clarify. Git is a distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It allows multiple developers to work on the same project simultaneously without interfering with each other's work. Git tracks changes to files, enabling developers to revert to previous versions if needed. Key features of Git include branching and merging, which allows for parallel development and integration of different features or fixes. GitHub is a cloud-based platform that provides hosting for Git repositories. It extends the capabilities of Git by offering additional features such as web-based interface, collaboration tools, issue tracking, and project management. GitHub allows developers to share their code with others, collaborate on projects, and manage their development workflows more effectively. It also supports the GitHub Flow workflow, which simplifies the process of creating branches, opening pull requests, and merging changes. Let's do a comparison and contrast. Regarding functionality, Git is a version control system that manages changes to files and tracks the history of those changes. It operates locally on a developer's machine and can be used independently of any online service. GitHub is a platform that hosts Git repositories and provides additional features for collaboration, project management, and code review. It relies on Git for version control, but offers a web-based interface and cloud storage for repositories. Regarding usage, developers use Git to manage their source code locally, create branches, commit changes, and merge code. Git can be used with any repository hosting service or even without one. Developers use GitHub to host their Git repositories online, collaborate with other developers, track issues, and manage projects. GitHub provides a centralized location for sharing code and coordinating development efforts. Regarding collaboration, while Git supports collaboration through branching and merging, it requires a shared repository to facilitate collaboration among multiple developers. GitHub enhances collaboration, providing tools for code review, pull request, and issue tracking. It allows developers to work together more efficiently and manage their projects in a centralized manner. With regards to accessibility, Git is a command line tool that requires installation on a developer's machine. It can be used offline and does not depend on internet connections. GitHub is an online service that requires an internet connection to access repositories and use its features. It provides a user-friendly web interface that simplifies repository management and collaboration. So in summary, Git is a powerful version control system that manages changes to files and tracks their history, while GitHub is a platform that hosts Git repositories and provides additional tools for collaboration and project management. Together, they offer a comprehensive solution for managing and coordinating software development projects. If you're following along with the learning path materials for this course, you will find a list of terminology that Git introduces, such as a working tree. It's a directory structure that contains all of the project files. A repository, which is commonly referred to as a repo, is the directory located at the top level of a working tree. It hosts all the project files along with the version history of those files. A clone is the action of creating a copy of a remote repository on a local machine that works on a project which you have access to. A fork is the action of creating a GitHub-hosted copy of a remote repository to work on a project that you don't have access to. A fork is typically used if you intend to contribute to someone else's project or create your own version of such a project. And while you don't have write access to the original repository, you can fully manage your fork. A commit is a snapshot of the changes made to the files in a repository at a specific point in time. Commits are used to record and save those changes. A branch is a named series of linked commits. In simple terms, a branch represents a distinct version of a project. This enables work on different parts of a project at the same time without affecting its main version. A merge is the process of combining changes from one branch, or commits, into another. This integrates changes from one branch into another. A pull is the action that fetches changes from a remote repository and merges them into the current branch. A push is the action that sends local commits to a remote repository, updating it with the changes made locally. A fetch is the action that retrieves changes from a remote repository without automatically merging them. This allows for a review before applying the merge. And finally, a pull request is a feature in a Git-based hosting platform such as GitHub that allows developers to propose changes and request merges into a target branch. A GitHub flow is a lightweight branch-based workflow that simplifies the process of managing changes to your code and collaborating with others. It's designed to be easy to use and flexible, making it suitable for a wide range of projects and teams. Now let's cover components of GitHub Flow. Create a branch, and this branch is where you will make your changes. I recommend a short, descriptive branch name to help collaborators understand the purpose of the branch at a glance. You're going to make your changes to the branch. This could involve adding new features, fixing bugs, or updating documentation. Your branch is a safe place to make changes without affecting the default branch. You're going to commit your changes to the branch with descriptive messages. Each commit should contain an isolated and complete change, making it easy to track and revert changes if necessary. You open a pull request, or PR, once you're ready to merge your changes into the default branch. This allows others to review your work, provide feedback, and suggest improvements. You review and discuss is where collaborators will review the pull request, discuss the changes, and provide feedback. This step ensures that changes will meet the project's standards and requirements. After the pull request is approved, merge the changes into the default branch. This updates the main code base with the new changes. Once the changes are merged, deploy the updated code to production or the appropriate environment. Continuous integration, or the CI portion of CI/CD, is a software development practice where developers frequently integrate their code changes into a shared repository. Each integration is automatically verified by running automated builds and tests to determine integration errors as quickly as possible. The goal of CI is to provide rapid feedback. This way, issues can be identified and resolved early in the development process. Here are some features of CI. Every time code is committed to the repository, an automated build process is triggered to compile the code and create executable artifacts. Automated testing, such as unit testing and integration testings, are run as part of the build process to ensure that the new code does not break existing functionality. Developers commit their code changes frequently, often multiple times a day, to ensure that code base remains stable and up to date. CI provides immediate feedback to developers on the impact of their code changes, allowing them to identify and fix issues quickly. CI systems are integrated with version control systems like Git, enabling seamless tracking and management of code changes. So what are the benefits of CI? By integrating code changes frequently and running automated tests, CI helps identify and resolve issues early, leading to higher quality software. CI enables faster development and release cycles by automating testing and integration processes, reducing the time between writing the code and delivering it to users. Frequent integration and testing reduce the risk of integration issues, making it easier to merge code changes from multiple developers. CI also promotes better collaboration and communication between team members by providing a shared repository for code changes and ensuring that everyone is working with the latest version of the code base. Automating the build and test processes reduces the time and effort required to build and test software, allowing developers to focus on their other tasks. We will be covering continuous delivery, or the CD portion, in another module, but I want to call out another set of terms that sound the same but are different. Continuous delivery is an extension of continuous integration, and you'll notice on the slide that they have both continuous delivery and continuous deployment. It ensures that code changes are automatically prepared for release to production. With continuous delivery, every change that passes the automated tests is automatically deployed to the next stage or environment. From there, the changes can be manually approved and deployed to production. The key aspect of continuous delivery is that the software is always in a deployable state. However, the actual deployment to the production environment is a manual step. CI and CD are complementary practices that together form a robust CI/CD pipeline. This enables teams to deliver high-quality software more efficiently and effectively. Shift-left testing is crucial for improving the quality and efficiency of your software development process. Shift-left testing involves moving testing activities earlier in the software development lifecycle, and traditionally testing is performed towards the end of the development process just before deployment. However, with shift-left testing, we aim to identify and address issues as early as possible, ideally during the development and integration phase. This approach helps catch defects early, reducing the cost and effort required to fix them later. Tests are run continuously throughout the development process, providing immediate feedback to developers. This ensures that code changes are thoroughly tested and validated at every stage. Shift-left testing promotes collaboration between developers, testers, and other stakeholders. By involving testers early in the process, teams can ensure that testing requirements are considered from the beginning. Automated testing tools and frameworks are used to streamline the testing process. This includes unit tests, integration tests, and other types of automated tests that can be run quickly and frequently. Here are brief descriptions, examples, and tools or products used for unit tests, smoke tests, integration tests, and acceptance tests. Unit tests involves testing individual components or functions of software applications in isolation to ensure that they work as expected. It focuses on the smallest testable part of an application, such as a function, methods, or classes. An example might be testing a function that calculates the sum of two numbers to ensure it returns the correct results for various input values. Tools that can provide this are JUnit and NUnit, and PyTest are popular tools for unit testing. Smoke testing, also known as build verification testing, is a preliminary test to check the basic functionality of an application. It ensures that the most critical features of the software are working correctly before proceeding with more detailed testing. An example might be verifying that the application launches successfully, that the main menu loads, and that the primary features are accessible without errors. Tools that can provide this are Selenium, Test Complete, and Apache JMeter. Integration testing involves testing the integrations between different components or modules of an application to ensure they work together as expected. It focuses on the interfaces and communications between integrated units. An example of this is testing the interaction between a web application's front-end and back-end components to ensure data is correctly passed and processed. Tools that can provide this are Postman, JUnit, and PyTest. Acceptance testing, also known as user acceptance testing or UAT, is performed to determine whether a software application meets the specified requirements and is ready to be released. It is typically conducted by end users or stakeholders. An example of this is testing a new feature in a web application to ensure it meets the business requirements and provides the expected user experience. Tools that can provide this are Cucumber, TestRail, and HP Quality. These testing types play critical roles in ensuring the quality and reliability of software applications throughout the development lifecycle. Shift-left security refers to the practice of integrating security measures early in the software development lifecycle. Traditionally, security checks and audits are performed towards the end of the development process just before deployment. However, with shift-left security, we aim to identify and address security vulnerabilities as early as possible, ideally during the development and integration phase. This approach helps catch security issues early, reducing the cost and effort required to fix them later. You should integrate security measures into the early stages of development processes, such as during coding and integration. This allows developers to identify and fix security vulnerabilities before they become more complex and costly to resolve. Automated security tests that are run continuously throughout the development process provide immediate feedback to the developer. This ensures that code changes are thoroughly tested and validated for security at every stage. Using shift-left security promotes collaboration between developers, security teams, and other stakeholders. By involving security experts early in the process, teams can ensure that security requirements are considered from the beginning. Using automated security testing tools and frameworks to streamline the security testing process, such as static application security testing, dynamic application security testing, and other types of automated security testing, enable testing to be run quickly and frequently. By identifying and addressing security vulnerabilities early, shift-left security helps improve the overall security of the software. This leads to fewer security issues and more secure products. Early and continuous security testing reduces the time required for final security checks and remediation, allowing teams to release software more quickly. Fixing security vulnerabilities early in the development process is generally less expensive than addressing them later. Shift-left security helps reduce the overall cost of development by minimizing rework and delays. Involving security experts early in the process fosters better communication and collaboration among team members, leading to a more cohesive and effective development process. Examples of tools for shift-left security are static application security testing, or SAST, S-A-S-T, are tools that analyze source code for security vulnerabilities without executing the code. Examples include SonarQube, Checkmarks, and Fortify. Dynamic application security testing, or DAST, D-A-S-T, are tools that analyze running applications for security vulnerabilities by simulating attacks. Examples include OSZAP and Burp Suite. Interactive application security testing, or IAST, are tools that combine elements of SAST and DAST to analyze running applications for security vulnerabilities. Examples include Contrast Security and Veracode. Dependency scanning tools like Dependabot and Sneak scan for vulnerabilities in third-party libraries and dependencies used in the application. Container security tools like Aqua Security and Twistlock scan container images for vulnerabilities and enforce security policies. Shift-left security is a powerful practice that helps improve the security and efficiency of your software development process. By integrating security measures early and continuously, you can catch vulnerabilities early, reduce costs, and deliver secure software more quickly. In this module, we covered the importance of source control and version control in DevOps. These practices are crucial for the achieving of continuous integration and infrastructure as code. Transitioning to a distributed version control model like Git is recommended, especially if you're using GitHub for software lifecycle management. Git allows for tracking changes, creating branches, merging branches, collaborating with multiple developers, and automating processes like continuous integration and deployment. The main takeaways from this module are that version control systems can be categorized as either centralized or distributed, with Git being the most popular choice for DevOps environments. The GitHub flow process helps streamline updates to GitHub-hosted projects. Continuous integration is a key component of DevOps that promotes collaboration and early detection of code quality issues. Shift-left testing involves moving testing activities as early as possible in the development phase to improve code quality and minimize operational risk. It includes unit testing, smoke tests, integration tests, and acceptance tests. Shift-left security is also important, integrating security activities early in the software lifecycle and continuously throughout development. I hope you enjoyed this module, and I look forward to seeing you in another module.